Students, what is that something inside microprocessor, which we call it as a digital units? In this video, we will see that component of microprocessor which is responsible for the processing and storage of data inside microprocessors. The registers, the ALU, which is nothing but the adders, subtractors, and units, OR units, NOT units, XOR units, and some more gates, and also control unit. So these three are the important digital circuit which is used in every microprocessor. Even the modern microprocessors or modern microcontrollers, these are the basic elements which is used to design an entire microprocessor. You will take registers. What is this registers? You all have studied D flip-flop in digital design. And the extension of D flip-flop lead to registers, which we call it as shift registers. So what we see here is 16 D flip-flops have been put in sequence, and we call it as shift registers. So this shift register not only can store 16-bit value, also it can shift right or left the whatever data stored in this shift register. So shift operations also can be done in these shift registers. This is not something new to you. You have already studied this in your previous course of microprocessor, which is digital design. Now in microprocessor, if you take 8086 microprocessor, the same shift registers have been racked, have been put in proper order. So there are many shift registers in microprocessor. For example, if you take 8086 microprocessor, there are 16-bit registers and there are 4 general purpose registers. The meaning of general purpose is that this is not dedicated to any special purpose, any specific purpose in microprocessor. These AX, BX, CX, DX, these are 4 separate registers, 16-bit registers, which can store value. Also, your ALU, your logical unit can read the value from this. After performing logic operations, the data can be stored back into this. So inside the microprocessor, these data, which has to be processed in a very important unit called as arithmetic and logic unit, has to be stored in these registers. So there are many registers put inside the microprocessor chip. Not only these 4 registers, there are other registers called a special purpose register, which are used to store the offset address of the memory, like stack pointer, base pointer, source index, destination index. SP corresponding to stack pointer, SP corresponds to stack pointer, BP corresponds to base pointer, SI corresponds to source index, DI corresponds to destination index. So while studying stack operation and also string operation, you will know the proper use of these registers. Ultimately, these four registers are used for a specific purpose of stack operation and string operation. And also, these general purpose registers not only gives a storage capability of 16-bit, it also can be used as two 8-bit registers, two separate 8-bit registers. That means in 8086, 8-bit operation is also possible. It not only performs 16-bit, if at all you want to perform any 8-bit operations, it is also possible. Because 8-bit operations are allowed in this, you can also use these 16-bit registers as a two 8-bit registers. And this is possible only in this AX, BX, CX and DX register. It is not possible for any other registers available in this microprocessor. So these microprocessor, when it evolves to the higher versions, we also see that it is compatible with the backward microprocessors data and its backward microprocessors programs. So totally we can say there are four general purpose registers and there are different specific purpose registers available in microprocessor. Not only this SP, BP, SI, DI, there are data segment registers, there are instruction register, there are core segment register and extra segment register, stack segment register. All these nothing but the same registers which I have told you in the beginning of this lecture. The same thing. This is something which you already studied from your digital design. Hope with this small video you must have understood about the registers which is used in the microprocessor. Good. We will continue with another lecture in the next video. Thank you for listening.